Two triangles are said to be similar when they are the same shape but different sizes. Corresponding angles are congruent and corresponding sides are in proportion. The notation that we'll use, if triangle ABC is similar to triangle DEF, we'll use this symbol. There's a tilde between the two triangles. In example 2, we're told the following triangles are similar. We want to list all corresponding angles and sides. Up first, let's look at the pairs of corresponding angles. Notice A and P have one arc on them each. So we can say angle A and angle P are corresponding angles. B has two arcs on it, as does Q. So angle B and angle Q are corresponding angles. C and R have three arcs on them. So angle C and angle R are corresponding angles. And now the sides we have to be a little more careful with because we're not given the labels. But notice between the one arc and the two arc, let's give it some notation. Between the one arc and the two arc, we have this line segment. So we can say that side AB is corresponding to side PQ. Similarly, between the one arc and the triple arc, one arc and triple, we can say that side AC and side PQ are corresponding. And then between the double arc and the triple arc, let's mark those, double and triple. That is side BC and side QR. Those are corresponding sides. In example 3, we are told that the triangles are similar. We want to find the ratio of the corresponding sides. We can do this multiple different ways. Notice the orientation of the triangles in this case are the same. Sometimes the triangles will be rotated in some manner like we see down here, so we do have to make sure that the orientation is correct first. Now pick any side. Let's do 25 divided by 20. We can reduce this. 5 will divide into both of those numbers. 25 divided by 5 is 5. 20 divided by 5 is 4. So the ratio of corresponding sides is 5 to 4. We can check that with another side. 20 divided by 16. 4 is the common factor this time. 4 will go into 20 5 times, and 4 will go into 16 4 times. We could also do that with the other side. 22.5 divided by 18. This one may be a little bit more challenging since we have the decimal, but we can do the division to help us a little bit. We get 1.25, which we can then convert to a fraction, 5/4. Notice the ratio is always the same. The ratio of corresponding sides is 5/4. In example 4, we are told that the triangles are similar. We're looking for the missing side. Looks like in this case we're looking for X. We can use the fact that the triangles are similar to set up a proportion. 25, the longest side of the first triangle, divided by the longest side of the second triangle, 10, is equal to the unknown x divided by 6. And once we set up the proportion, we can cross multiply to solve. 25 times 6 equals 10x. 25 times 6 is 150. That's equal to 10x. We then need to divide both sides by 10 to isolate the x. And we get x is 15. In example B, notice that the triangles have been rotated slightly, so just be careful with the orientation. But we are told that they are similar, so we can still use the proportion setup. I'm going to use the longer side, 10, divided by the longer side, 5. And we'll set that equal to, we want to use 8 because it's the corresponding side to the unknown x. So we'll do 8 divided by x. Now cross multiply, we get 10x equals 5 times 8 is 40. Divide by 10. And that unknown side is 4. A football player stands 6.25 feet tall and casts a 3-foot shadow. At the same time, the stadium which he is standing next to casts a shadow of 90 feet. How tall is the stadium? Let's sketch a picture. Let's say this is the stadium. We don't know its height. We're actually looking for the height of that stadium. But we know that it casts a shadow of 90 feet. So the shadow that's on the ground is 90 feet long. We can draw a triangle to help us set this up. And we have a player that is 6.25 feet tall. We know his shadow is 3 feet. Let's draw a triangle for that as well. Notice now we have similar triangles. I'm going to label this height as x. Let's set up a proportion. X over 6.25 is equal to 90 divided by 3. We'll get 3x equals 90 times 6.25. 90 times 6.25 is 562.5. So 3x equals 562.5. We then need to divide by 3 on both sides. This gives us x is 187.5. The units in this case feet. So we now know how tall that stadium is. 187.5 feet.